Hey guys, this is some notes for Chapter 20, Section 7, where we learn about solenoids. Solenoids are really cool devices. I'm going to show you some pictures and talk about some of the applications for them. But essentially what it is you take a wire that's connected to a circuit and you wrap it around usually an iron core. Let me show you some pictures of what they look like. You can think of this as a solenoid. Think of putting an iron core in there. Here's another example. And what happens is, we talked about how wire, when you run a current through it, creates a magnetic field around it. There's a relationship between magnetic fields and electric current. And so as we run current through this wire, it creates a magnetic field. Well, that's always true. But when you do loops of wire next to each other, that magnetic field builds and builds and builds and becomes stronger and stronger and stronger. Now, the way this works, it still follows what we call the right-hand rule. There's a right-hand rule for wire. And the way that it works is you put your thumb on the wire in the direction of the current. So you can imagine grabbing this wire right here with your thumb pointed downward. Okay? Your fingers, as they curl around the wire, would go inside of the loop pointed from the left side to the right side. That's how we know which direction the magnetic field builds. But because of the loop after loop after loop after loop, all of these magnetic fields build up on each other, and inside here we get a very strong magnetic field. This is how we build what are called electromagnets. If I put a nail through here, or some sort of an iron rod, and I run a ton of current through there, that rod will become magnetic. It'll magnetize, and I can use it to pick up really heavy objects. The more current we run, the stronger this magnetic field is going to be. And the more loops I run, the stronger the magnetic field is going to be. In fact, the equation that we would use to describe how the current and the loops and the size, because if this thing is really tightly wound and so it's not taking a lot of length, because obviously this wire here is not going to impact this wire if they're really far apart. Okay, so in here we can talk about the application of solenoids. Sorry, I kind of got off track there. I had a student come in online. But we've got our solenoids. We know which way that the current's gonna, or the magnetic field's gonna flow based on the direction of current. These get used in all kinds of valves and real life applications. You can see right here, okay, we have our core, and as it yanks or pushes on this iron core, okay, as the current or magnetic field pushes down on that, it's going to close this valve that's flowing through here. It's going to cause a stopping of the flow of some sort of fluid or gas. They're called solenoid actuators. They're very, very good at producing consistent results that only rely on basic access to electricity. And there's something that we can, very few moving parts to break down or have problems with. Let's look at our equation here and how it works. So the magnetic field inside of a solenoid is going to equal mu naught, which is always 4 pi times 10 to the negative 7th, times the current that runs through the solenoid. So big current means big magnetic field, but you also have to have a thicker wire in order to do that, times n, the number of loops, all divided by the length. This is the cost. If you think about running, really thin layers of wire, right? Lots of thin wire. You can run a lot of layers. If your wire is thick, then it's going to get, the solenoid is going to get wide really fast as it comes around and around and around and around. The thicker the wire is, the longer the solenoid becomes as you wrap it again and again and again. So there is a cost benefit to putting thin wires but using less current, and using more current but having to use thicker wires. But here's our formula. It's really straightforward. The problems you're going to look at today will be it's pretty simple to work with. Just asking about the magnetic field inside of a solenoid. But I wanted to talk to you a little bit about the textbook. This is a really cool chapter to read, or section to read. It talks a lot about electromagnets and their application in generators, producing large magnetic fields, things along those lines. It doesn't take power, it just takes electrical energy, but it doesn't consume power through this solenoid. one of the really cool things is just cool applications you can kind of understand is this idea of how an old iron bell would work. And the basic idea is there'd be a spring holding this iron rod to the left. We would flip the switch, like press a doorbell, and this solenoid right here to the right would start to pull. Using the magnetic field would start to pull on this iron rod, make it want to come to the right. Well, it gets pulled to the right and that spring gets compressed. It's going to hit this bell over here, but due to the spring being compressed, it's going to be shot back to the left. But as it's being pulled to the left, that solenoid is saying, no, get back over here using magnetic fields. So it's pulling back to the right. And so there will be this back and forth vibration that will cause the iron rod to strike the bell several times a second, creating what we've traditionally considered the bell sound that you hear at school and things like that. Now, today we use electronic sounds, but back in the day we used actual iron bells with iron cores in them, and we use this same kind of skill, the same type of learning and understanding to do all kinds of valves and actuators in electricity. Everything from how we modify medical parts to use less moving pieces and to just have an on-off valve. I mean, these can be used in all kinds of sophisticated systems in plumbing and water distribution, gas leaks, things like that. We can use this. It's very simple to apply to a system. Very, very reliable. Very cool stuff. I love solenoids. I love the concepts of what they're able to do just by turning a switch, the ability to turn things on and off. If you have questions, come see me. But this should be enough to get you through the couple homework problems you have on 48 through 49.